Hi everyone, welcome back to the channel. In the last video, we explored how to train an object detection model using YOLOv11. But in today's video, we're going to do something different. We will train an image classification model from scratch using YOLOv11 class. Here class means classification. So first of all, let's understand what image classification actually is. In object detection, our model draws bounding boxes around objects in an image. For example, a cat here and a dog there. Maybe even multiple objects in the same thing. So if I just Google it, so if you see here, this is classification of a cat and this is object detection. That's totally two different things. And as you can see that in image classification, there are no bounding boxes. Instead, the whole image is classified into a single category. So if we go to another picture, which is like this, images, model, and a dog, wolf, and a cat. So if the model has 10 classes, it will simply predict which class the entire image belongs to, with the probability score for each classes. So now let's talk about the dataset preparation. For object detection, we needed tools like RoboFlow to label images one by one, which took really long time. But for image classification, it's much easier. We just need to create a folder for each classes and put the images inside. That's it. So for example, if I go to the code base, you can see here I have a dataset called seafood. Here we have train folder and test folder. Inside the train, we have hot dog. As you can see, these are all the hot dogs and not hot dog, which are this. You can't find any hot dog inside this folder. So for example, if I want to build a model called fast food classifier with 10 different categories like burger, pizza, fries, hot dogs, and so on, I'll just create 10 folders, one for each food item, and put the images there. For this demo, as you can see that I have already shown what this means. And same goes for the test. Hot dog and not hot dog. That's it. So that's all what we need for classification dataset. So now it's the time for choosing the right model. Since I'm in this video, I will go for the smaller models, but you can try larger models. So first of all, let's check that CUDA is really installed or not. This is the code, simple code. Just run. Yes, my CUDA is perfectly installed. Now let's go to the training notebook. This is the code base. It shows whether GPU is really installed or not. And you can see that it's perfectly showing all the thing. There's the alternatives library where we are importing YOLO. And the final thing is YOLO class, which means classification. It has S, which means smaller, but you can have a smaller model like N, which stands for nano. So nano, small, medium, large, and XL, which is ultra large. So in this video, I will choose the smaller model. So let's run this model. It's downloading the model, which is already 13 megabyte. It's downloaded. Now, inside the data parameter, we'll put the path of the main dataset, which is this. So dataset / seafood. And for the epochs, we'll be using 70, which is decent. And the image size is 224. You can choose any size you can want. And the batch size is 32. So let's run the model. So there are 500 images, which will take some time. So in this arguments, you can see the output parameter is 2, which means either it's hot dog or not hot dog. So it has 2 last neurons. If I open the task manager, You can see the GPU is perfectly using, and here's the training process is started. So it's too fast. You can see it's only taking 800 megabytes of VRAM, which is very small compared to the object detection. Because with object detection, we have to use a lot of parameters. For example, smaller models require 13 or 14 million parameters. You can see the loss are getting smaller. The first loss was 0.70, then 0.37, then 114, 0.10, 0.09, 0.6, which is really small, 0.3, 0.2. At some point, you will notice if we use larger epochs, then the model will overfeed. We have only 9 epochs left. It's done. The kernel is crashed. It's not a big problem. So in the runs folder, you can see the matrices are done. And the train batch is 0. 0 means it is hot dog. And 1. Oh, it is hot dog and not hot dog. Hot dog and not hot dog. Same goes for validation batches. Okay. Since the terminal is crashed, we have to restart it. And now use the models folder, which is weights. Inside the runs, classify, train, and the weights. Here the base.pt file, which is the final model file, which is this. So let's clear all outputs, import this. Since we have already trained the model, we don't need to run this two part. We'll just use this line. And let's test the model. So for that, we'll need some dataset. If I use this image, so its name is 138933. You can see the hot dog probability is 100% and not hot dog. Yes, it's hot dog, so it's correct. Now, if we see the test images from not hot dog and then run it, we can see not hot dog probability is 100% and hot dog is 0%, which we really wanted. And the speed is really fast, which is only 2.5 millisecond and 35 millisecond for the inference. And it took only 0 seconds for post-process per image, and the image shape is this. Because 1 for one image, 3 for RGB channel, and these are the image dimensions. So that's it for today's video. If you like this video, give it a thumbs up, and if you have any questions, then please comment it and I'll try to answer them. Best of luck. Sayonara.